All right, the difficult thing about this isn't going to be graphing it, I hope. We're going to have 1, 2, 3, 4 distinct ordered pairs on this graph. One at negative 3, 4, there in the second quadrant, negative 2, 4 right next door, negative 1, down in the third quadrant, and 3, -1 down in the fourth quadrant. Do not connect these. These are 4 distinct points. You should be able to count them. If you were to connect any of them, you'd no longer have 4 points. You'd have like infinite points, because on every segment there are infinite points. So do not connect these. They do then want us to state the domain and range. The domain is the set of all x values. There's a -3, a -2, a -1, and a +3. If any of those had been repeated, we would only write them once. For the range, we're going to experience that. There's a 4, a 4, a -1, and a -1. There are some repeats here, so I'm only going to write the -1 one time and the +4 next time, one time. If you put the 4 first and the -1 second, technically that's not wrong. I just like putting things in order. Then it says determine whether the graph is a function. It is. This would pass the vertical line test. No matter where you drew a vertical line on this thing, you'd only cross 1 point at the most. Therefore, this is a function. And is it 1-to-1 onto both or neither? Well, it's not 1-to-1. The reason is it does not pass the horizontal line test. Right here, you'd cross 2 points on the graph. Right here, you'd also cross 2 points on the graph. So it is not 1-to-1. The question then would be, is it onto? And when it's listed in the set, you could say, yeah, it is onto. Onto is a little tricky sometimes. Because in the set here, yeah, it's onto. Every single y value is being used. However, once you display it on a graph, you're only using y values at -1 and at 4, but you're leaving all these other y values open because you put it on a graph. So you're showing infinite y values. So it's not even, it's not onto either only because it's on a graph.